All right, so I've got the day packed completely full, just the way I like it. So I've got about a half an hour here for a new series. So I finished the end of Python for DevOps, and I'm ready to move on. I've created a few collections. I've created a collection for the books I've finished reading, which is Python for DevOps. Unfortunately, really haven't finished reading any of the other books in here, and these are all books that I paid for, which I don't know. I'm considering at some point getting like an actual Kindle because I feel like the way I consume information is very problematic. I do watch a lot of YouTube. There is a you can see I curate it pretty carefully. So Dave's Garage is a great channel. Connor Leahy is a great figure to follow. So like, and then there's some decent information on YouTube. Kind of starting a new hobby uh, for Olympic weightlifting. So, it's not all bad, but I feel like it's not as good as books. That's what people will tell you is to read books, and they tell you to read paper books, but I think a good compromise is to get a Kindle and read published books on the Kindle instead. So anyway, I have been doing that. I've just been reading technical books, and I've been reading them out loud on this channel. So let's move on to the next book. The next book is going to be Machine Learning for Network and Cloud Engineers. All right, so I'll go all the way back and look at the cover. So get ready for the next era of network automation. And this is by Javier Zantich, and it's got a foreword by Evan. And these are probably two good entries for LinkedIn. So I think I'm going to do that. So here we go. I will start off this series by adding the authors on LinkedIn. And then you can actually go one step ahead, and I recommend doing this. And not only add them on LinkedIn, but look them up on YouTube and see if they have like a really solid channel with a lot of like really well made content, not like my channel, like a real professional YouTube channel. If they do, then go ahead and add them. Okay, so this is the book author here. So I will. Oh, and I'm actually already following this person. So yeah, let's go one step ahead and let's see if they have a YouTube channel. Is he okay? So we've got a channel here called the Cloud Gambit. We've got one here called the Linux Foundation. Those all look like really good channels. I'm already subscribed to the Juniper Network channel, but this looks like a pretty solid channel. So let's subscribe to this one. And then this, I'm kind of surprised I'm not subscribed to this already, so I'll subscribe to that. And I'm subscribing on my professional channel. I kind of don't want to declare up my other one. Okay, so there we go. So the copyright is 2023. So this is fresh off the hot off the presses. The last book was in 2020. This was published last year. Disclaimer: this book is a personal project. Therefore, any opinion, technology recommendation, consideration, or strategic view is of my own. They are not necessarily aligned or related to the opinions and views of my current or former employers. And that same goes for me. I have that disclaimer clearly posted on my channel. And I just want to reiterate that applies to this channel and myself as well. No network, cloud, or ML model were harmed during the writing of this book. That does not apply to me. I will be breaking a lot of things. In fact, I will say right now, a lot of networks, clouds, and machine learners will probably be harmed, but it'll just be in my home lab. To my wife, Sarah, and my kids, Zoe and Mark, they are my all and everything. Okay, great. So now here's the contents. Don't have to just read the contents, but maybe a bit of a sense of what we're going to start with. So we'll start with the, let's see here. So start with some kind of, we'll go into like some more formulaic things. UC. So here we go. We're going to start with the foreword. Artificial intelligence, AI, has been around for decades. It was one of the exciting, emerging, and overhyped topics when I attended university in the late 1980s. Like today, the hype failed to deliver, resulting in long AI winter. And one thing that's really funny, if I'm allowed to already go off on a tangent, which I'm quite good at doing, is the father of the information age is a juggler named Claude Shannon. In his spare time, he likes to invent things like how to store data on disks and the fundamental basic mathematical principles that allow the internet. But there's kind of a funny video of him giving a demonstration on AI. So let's see if I can find that video. I'm going to type in AI. Yeah, so here it is. Let's watch this video quick. It's pretty short.
The thinking machine.
Hello again. With me tonight is Professor Jerome B. Wiesner, Director of the Research Laboratory of Electronics at
Of the computers. I've got plays pretty.
Humans require intelligence.
For a very long time.
Little electronic brain.
All right. Well, this isn't the video. The video I was thinking of was, if I search for mouse, I'll probably find it. Oh yeah, this is it. So he demonstrates machine learning, using, yeah. And this is shorter, great. So what he's going to do is have this mouse find the way to the end of the maze using AI in the 40s or something. I don't even know.
He has the ability to solve a certain class of problems by trial and error means, and then remember the solution. In other words, he can learn from experience. Like his classical namesake, Theseus has the problem with finding his way through a maze. His objective is the goal here in the corner. He is now exploring the maze using a rather involved strategy of trial and error.
Yeah.
As he finds the correct path, he registers the information in his memory.
Okay.
Later, I can put him down in any part of the maze that he's already explored, and he'll be able to go directly to the goal without
Link
making
state
a single
protocol.
false turn.
Or wait. Yeah, because he's using an algorithm to like build a map of all the thing. Yeah, so just wanted to show that because that's machine learning, that's AI, that's the sad story state it was in, and only until recently is it in a state that's like actually exciting. So this book actually might be a little bit out of date, even though it was published last year with how fast things are changing. The situation has changed drastically in recent years. AI solutions can recognize images, play chess or Go, and try to appear semi-intelligent in casual conversation. You can guess what the results of this unexpected progress might be. If you want to get your startup funded or your project approved, it must mention artificial intelligence or machine learning, regardless of whether that makes sense or not, resulting in another wave of mostly misguided hype. The networking industry is no exception. Every vendor is talking about artificial intelligence, even if their product contains nothing more than a long list of if-then-else decisions. Does that mean we can safely ignore the AI/ML hype and keep doing what we have been doing for the last 50 years? Of course not. AI/ML technologies are at a point where they are worth considering outside of academic environment, but not without a hefty dose of critical thinking. The next obvious question is thus: where could I get unbiased information? Where could I get the unbiased information I need to evaluate whether AI/ML makes sense for the problem I'm trying to solve. A few years back, I got an out-of-the-blue email from Javier Antich. Remember, this is a foreword written by someone else. Javier is the author of the book. Arguing about intricate details of identifying malicious domains from DNS traffic. He was clearly an expert with a deep understanding of AI technologies beyond the currently hip neural networks. Yeah, so last year, and their networking applications. He was kind enough to create an IPspace.net webinar with a very appropriate title: AI/ML, the good, the bad, and the ugly, in which he discussed AI-related technologies, their use cases, advantages, and drawbacks. Not surprisingly, that webinar has been a huge success, receiving tons of accolades. So I do want to go to ChatGPT quick. I want to see when it was first released. When was this program, ChatGPT, first released to the public?
The program ChatGPT was first released in public by OpenAI in November 2022. This release featured...
Okay, so ChatGPT was released before this book was written. That's great. Most webinars have just one tiny problem. Discussing all the relevant quirks and nuances is usually a mission impossible due to time limitations. Fortunately, Javier solved that problem and wrote a deep dive book that you obviously own. Congratulations. Covering the same set of topics in way more detail. While it's always good to have a detailed discussion of multiple related technologies, he went a step further and created almost a dozen scenarios, from detecting outliers and anomalies in network behavior to clustering. What devices do I need? Forecasting. How many subscribers will I have? And even natural language processing to analyze router configurations. To make the scenarios even more realistic, he created a network simulation tool and published all the source code on GitHub, allowing you to try them out with little extra effort beyond installing the necessary software. Oh, that's cool. So you get like a lab to play with. I'm pretty positive that you'll find at least one of his use cases applicable to your network, and when you do, dig deep into the technology chapters to figure out why it works and how to adapt it to your environment. I wish you good luck in exploring the AI/ML world, and hope you'll find Javier's book a worthy companion. So the foreword was by Ivan Pepelnajak or something. Pepelnajak. I don't know how to pronounce what appears to be a Slavic name to me. All right, so let's see if he's on LinkedIn. You know what? Can I follow? I am already following. You know what? This is cool, because this is kind of a clashing of worlds. Anyone who's familiar with this channel, I hope, is familiar with David Bomble's channel, and Ivan is a frequent guest star on that channel, so that's cool. He's definitely got some. That's a good get for a foreword for a book. So kind of a lot of credibility to this book added through that. Cool. Yeah, and again, David Bumble. There is some criticism of channels like these that I think can be valid, but there's kind of no harm in subscribing, and you know, if there's something good. There is harm in being addicted to social media and neglecting your duties. But I feel like David Bumble especially kind of has his finger on the pulse it's just there's a lot of focus on it's entertainment. I would say, like, what I'm doing right now is reading a technical book, and I think that's what if anyone's watching this, should be doing too. I think just for fun, and to kind of get a finger on the pulse, this is a great channel, so I recommend it, and it's cool that a featured highly esteemed guest on that channel is the wrote the foreword to this book. All right, so moving on. Acknowledgments. Multiple individuals have contributed to his book, implicitly or explicitly. So I guess Ivan wrote the acknowledgments. Yeah, I don't need to read the acknowledgments. I'm just skipping it through. I don't think I need to add all these people on LinkedIn. You know what? I think I'm going to do that cuz, like, you know, that's I think I am going to follow these people on LinkedIn. As I said before, I don't like to follow too many people on LinkedIn to get, like, you know, the wrong kind of content. And this is going to be a lot of work to, like, track down who these people are, especially with more common names. So, you know what? I'm going to skip it. It's just a waste of time. Why is AI/ML relevant for network and cloud engineers? What is in it for you in AI/ML? You are a network engineer primarily focused on the network technologies you need to deal with. BGP, MPLS, SR. What is SR? Okay, well, I'm kind of upset that I don't know what SR is. Spine leaf, EVPN, etc. All right, well, let's go to ChatGPT and let's get up to speed on that. I'm kind of disappointed in myself that I don't know what that is. I feel like I do know what that is. It's like service routing, or I don't know. I feel like I could make up what it is, but I want to get the truth and not have to unlearn false information. I just don't know what SR is. So, tell me what SR is. I'm disappointed in myself that I do not know, as I am a professional. I am very familiar with all the other terms. In addition to telling me what SR is, tell me how problematic it is to my success as a professional that I didn't already know. Segment routing.
SR stands for segment routing, a network protocol designed for simplifying the management and operation of network infrastructure, particularly in large-scale service provider and enterprise environments.
Really?
Segment routing can operate over MPLS, multi-protocol label switching, or IPv6 DAV lanes, referred to as SR-MPLS and SRv6, respectively. In segment routing, the path the DAV packets take through the network is determined by a list of segments attached to each packet. These segments are identifiers that represent a specific instruction, like routing through a particular path or performing a specific function. This approach eliminates the need for multiple protocols and simplifies traffic engineering, as the network does not need to maintain state information for each flow. Regarding your concern about not knowing SR as a professional, while it's important to stay updated with relevant technologies in your field, not knowing one specific technology shouldn't be overly concerning.
Okay, I know all the other
The field
ones.
of network engineering is vast and constantly evolving.
Cool.
It's common for professionals to specialize in certain areas while having less exposure to others.
Thank you.
The key is continuous learning and adaptability. The absence of familiarity with SR until now does not greatly impact your success as a professional, especially since you are well versed in other key network
Yeah.
technologies like BGP, MPLS, and EVPN. However, as networks continue to evolve toward more programmable, automated architectures, technologies like segment routing are becoming more prominent. Therefore, it might be beneficial to start exploring segment routing and related technologies to ensure you remain competitive and well prepared for future developments in network engineering.
So tell me more about segment routing then. Like, when was it first introduced? Which vendors are really like excited about it and advertising it and using it? Are there any networking vendors that don't use it? Are there any environments where it wouldn't be used or where it would be used? I actually have a lot of experience in service provider networks, so that makes it extra surprising to me that I did not know about segment routing. Now tell me this, if you were to tell me the particulars of segment routing, like what constitutes segment routing, maybe I would know what segment routing is then. Maybe it's just that I don't know the general shorthand term for broader technical details that I am very well familiar with. Could this be the case? Yes, please.
Certainly, let's delve deeper into segment routing, SR, its origins, adoption by vendors, and its practical use cases. This might help clarify whether the concepts are familiar to you under a different name or context. History and introduction. Segment routing was introduced around the early 2010s. It emerged as a solution to streamline and simplify network operations by removing state overhead from the core of a network, thereby enhancing scalability and operational efficiency. The protocol's development was driven by the need to enhance traffic engineering without the complexity that traditional approaches required, like RSVP day. Key vendors and adoption. Major network equipment vendors quickly recognized the potential of segment routing. Cisco has been a major proponent of segment routing. They've integrated SR capabilities extensively across their routing platforms and have been pivotal in promoting SR, especially SR over MPLS, SR-MPLS. Juniper Networks also supports segment routing in their products, offering solutions tailored toward both service providers and enterprise networks. Nokia, via its Alcatel-Lucent acquisition, has implemented segment routing in its service routing platforms. Huawei is another key player promoting SR, particularly in markets where they have a strong presence with service providers. These vendors and others have been integrating SR into their offerings, targeting environments where network scalability, flexibility, and service quality are critical. Environments where SR is used or not used. Segment routing is particularly beneficial in environments that demand robust traffic engineering, fault tolerance, and network simplification.
Yeah, it's
Service
like
provider
core
networks.
stuff.
SR is
I didn't do a
extensively
lot
used
of
for
core
optimizing
stuff.
network paths and improving the delivery of services. Large enterprise networks. Enterprises that manage complex internal networks often use SR to simplify operations and enhance performance. However, there might be environments where SR is less relevant. Small networks. In smaller, less complex networks where advanced traffic engineering and path segmentation aren't required, the benefits of SR might not justify the implementation overhead. Older legacy networks. Networks heavily reliant on traditional routing protocols and with less demand for new traffic engineering solutions may not see immediate benefits from adopting SR. Understanding segment routing. Better. Here's a breakdown of what constitutes segment routing. Segment routing header, SRH, for SRv6. This is an
Yeah,
IPv6
this is
extension
all
header that contains the
different.
segment list, a set of instructions defining the path of the packet through the network.
I don't know any of this.
Segments. These are the building blocks of SR and can be thought of as instructions. In SR-MPLS, they are MPLS labels. In SRv6, they are IPv6 addresses that direct the packet through specific paths or perform specific functions. Traffic engineering. SR allows explicit routing paths to be built dynamically and adjusted as needed without state changes in the network core. Did you already know SR? If your experience involves detailed MPLS configurations, traffic engineering, or explicit path setups using protocols like RSVP day, you might already be familiar with many concepts central to SR.
Yeah, I know
Specific
this.
terminology, like segments or the use of an SRH, and the mechanism of embedding instructions directly into packets might be the aspects you hadn't associated with the term segment routing. If you have been involved with detailed path controls and optimizations in service provider networks, you likely have encountered the foundational ideas of SR under different guises or perhaps more specific technical implementations. The innovation of SR mainly lies in how it simplifies and consolidates these operations.
Okay, so let's say that I primarily worked on the network edge on the service provider and not so much on the network core. Could this be a reason why I haven't seen SR enough to be familiar with what it means in this context? Also, tell me if I went for the JNCI ESP exam. So the JNCI ESP, the JNCIE, the Juniper JNCIE exam. So like that exam, if I went for the service provider track of that exam and I made it far enough to score points on the exam but not pass it, would I have learned about segment routing? Also, if I had earned the CCNP in the enterprise track, would I have learned about service provider routing? I earned the CCNP around 2016 or so, or like 2015. The JNCI ESP, the JNCIE I attempted in 2020. Is it surprising that I don't know about segment routing given my experience with studying networking and my professional experience? Okay. Yeah, it'd be more in the core.
Given your background, especially focusing on the network edge and service provider environments rather than the core, it's quite possible that you hadn't encountered segment routing extensively.
Okay.
Ed roles often deal more with connecting clients and external networks, managing protocols directed toward customer connectivity, VPN services, and sometimes broader traffic management without deep involvement in core traffic engineering mechanisms like segment routing.
Yeah.
SR typically plays a more central role in core network operations where optimizing path efficiency and scalability are crucial. Relevance and certifications, Juniper JNCIE SP exam. If you attempted the JNCIE for the service provider track in 2020, you would have likely encountered segment routing concepts.
Yeah, I mean, I didn't
The
pass.
JNCSP exam covers advanced routing technologies and techniques, including traffic engineering and MPLS technologies, among which segment routing has become a significant component. While not passing the exam may have limited the depth of your exposure or retention to specific topics like SR, it would typically be covered in study materials or preparation courses for this certification level.
Okay.
Cisco CCNP Enterprise Track. The CCNP and the Enterprise Track, which you earned around 2015-2016, would have primarily focused on enterprise-oriented routing and switching technologies. Topics typically include advanced routing, layer 3 technologies, VPN services, and some traffic engineering, but with a focus suitable for enterprise applications rather than service provider networks. The introduction and integration of segment routing in mainstream certification tracks have increased over time, and its emphasis in an enterprise-focused certification from that period might not have been very pronounced. Is it surprising you're unfamiliar with SR? Given these circumstances, it's not particularly surprising that you're less familiar with segment routing.
Okay.
Your role concentrated
Cool.
more on the edge rather than the core, where SR is more prevalent.
Yeah.
Certification content. While SR might have been part of your JNCSP stay, not passing the exam could imply that either the SR components were not equally
Right.
utilized, or they were one of many topics.
Yeah.
In your CCNP Enterprise Track, SR might not have been a major focus,
Yeah.
aligning more with traditional enterprise routing solutions.
Okay.
Continuing education and staying updated with the latest developments in your field is crucial, especially in technology domains that evolve rapidly like network engineering. Given the increasing relevance of segment routing in modern network architectures, it can be beneficial to explore current training resources or certification updates that include newer technologies and protocols like SR. This can enhance both your understanding and adaptability to evolving industry demands.
Cool. That was already awesome. I'm glad I did that. So yeah. So what is in it for you with AI/ML? You are a network engineer, primarily focused on the network technologies you need to deal with: border gateway protocol, multi-protocol label switching, segment routing, leaf/spine style architectures, and virtual private network. Ethernet virtual private network. I think it's Ethernet virtual private network. Does the E in EVPN stand for Ethernet? Oh, yes, I got it. Okay.
Yes, the
I'm
E in
perfect.
EVPN stands for Ethernet.
Mr. Perfect over here. All right, standing. Okay, well. Okay. All right. Moving on. And very likely also familiar with the automation techniques necessary for the network or technology you are responsible. Ansible, I have a whole annoying series on that. Nor I haven't really used that much. That's from Kirk Byers, from what I understand. Then SaltStack, NetConf I've used, and then gRPC/gNMI. So I'm kind of not familiar with. I'm familiar with less of these than I am of these. Ansible, I'm pretty well familiar with, and I have a whole series on this channel for. NetConf, I'm pretty well familiar with. I had a lot of work I had to do professionally with NetConf. Nor I'm somewhat familiar with because I'm familiar with the stuff Kirk Byers does. SaltStack is just kind of like I'm familiar with it because of it's on like exams. And then this one I'm actually not familiar with at all. Among others, why would AI/ML be relevant for you besides the fact that learning something new is always good? Okay, so let me ask the AI about that once. So, so let me get the whole part. There, and then paste it in. And then I will say, I am... Okay. Tell me about it.
gRPC and gNMI are two important technologies in the context of network management and automation, especially as networks move toward more software-defined and programmable infrastructures. gRPC Remote Procedure Calls is an open-source framework initially developed by Google. It enables efficient and robust communication between services in a distributed system. gRPC uses HTTP2 as its transport protocol, providing significant improvements over HTTP1x in terms of speed and efficiency. The DAT format used in gRPC is protocol buffers, often shortened to protobuf, which is a language-neutral, platform-neutral, extensible mechanism for serializing structured data. Key features of gRPC include multiplexing. Multiple requests and responses can be sent over a single connection simultaneously. Bidirectional streaming. gRPC supports streaming requests and responses, allowing for continuous data flow. Strongly typed contracts. Service contracts are defined in a specific interface definition language, IDL, which helps in generating efficient, safe, and accurate code across different languages. gNMI, gRPC Network Management Interface, is a protocol built on top of gRPC designed specifically for the management and configuration of network devices. It was developed as part of the OpenConfig project, which is an effort by a group of network operators to define vendor-neutral data models for managing network devices. gNMI uses gRPC as its underlying transport and provides several services for network management capabilities, querying the device for the data models it supports. Get, fetching data from a device using a variety of encoding formats. Set, modifying state on a device, including configuration changes and subscriptions to telemetry data. Subscribe, establishing subscriptions for streaming telemetry data from network devices in real time. Applications in network engineering and network automation and management, both gRPC and gNMI offer significant advantages, efficiency and performance. gRPC's use of HTTP2 enables more efficient communication, which is critical in high-performance networking environments. Cross-language support. gRPC and protocol buffer support code generation in many languages, making it easier to integrate diverse systems. Real-time network state monitoring. gNMI's subscription mechanism allows for real-time monitoring of network states, which is crucial for dynamic and responsive network management. Conclusion for a network engineer, familiarity with gRPC and gNMI can be crucial for modern network operations, especially in environments where scalability, speed, and real-time data are critical. They are particularly relevant in contexts involving extensive use of network automation tools and when managing large-scale or multi-vendor network environments. Understanding these technologies can greatly enhance the capability to design, deploy, and manage complex network infrastructures efficiently.
That's interesting. Show me a quick example of the basics of using this.
Sure, let's dive into a simple example to illustrate how you might use gRPC and gNMI in practice. We'll look at a basic scenario where you'd want to retrieve information from a network device using gNMI. I'll outline the steps to set up a gRPC client, define a gNMI service, and then use it to fetch data. Prerequisites: protocol buffers in gRPC. Ensure you have gRPC and protocol buffers installed in your development environment. Network device. The network device must support gNMI. Step 1. Define the profile for gRPC and gNMI. You first define the service and messages in a profile. This example assumes we are using existing OpenConfig protobuf definitions for gNMI, which are publicly available. Step 2. Generate client stubs using the profile. Generate client stubs for your programming language. For example, in Python, you would use this command generates Python files from the profile, which include classes and methods you can use directly in your code. Step 3. Write client code. Here's a basic Python script to connect to a device and send a gNMI GET request. Explanation channel setup. Establish a connection to the device. Device IP 50051 is a placeholder for the device's IP address and port. Stub creation. Create a stub to interact with gNMI services. GET request. Prepare a GET request for specific data, such as interface information. Here, we query for data related to Ethernet 1. Fetch and print. Send the GET request and print the response. Note the actual data paths, request setup, and handling will depend on the specific device's data models and the gNMI service capabilities it exposes. In production environments, you should use secure channels, gRPC, secure_channel, with appropriate authentication and encryption. This example is fairly simplified to illustrate the basic steps. In a real-world application, you would need to handle more complex scenarios, including error handling, more sophisticated request configurations, and potentially processing large amounts of returned data or streaming telemetry.
All right, so that's all I want to spend on that. So moving on to the next page, and I can close the contents here. Networks and cloud infrastructures operate under the conditions determined by the configuration state that has been pushed. We have talked, and to some extent we are also using, about intent-based management, where, and no, we haven't. What do you mean? You mean like in his workplace? Where we didn't talk about that. It's on 2% of the book. That's poorly written. We have talked, and to some extent we are also using about like where. I think what the author means to say here is, in my professional experience, we have talked and to some extent have also used. Sorry, I think what the author is intending to say here, and it's written very badly, is in the author's professional experience, they have used to an extent, and talked about to a larger extent, intent-based management, where an intent is a definition of a desired state on the infrastructure, frequently characterized by a particular configuration, but not limited to it. Intents may also include operational state. As network engineers, we have to execute maintenance operations or activate changes. Examples of the same are software upgrades, configuration changes, restart components, provision and activation of new components such as line cards, interfaces, nodes, etc. Driven by the digital transformation, both in enterprises and our personal lives, the network and supporting IT and cloud infrastructures play a more crucial role than ever in our daily lives. The expectation of reliability and performance are higher than ever because a good portion of our activities relies on them. On the other hand, the increase in users, devices, and services has also resulted in the unprecedented evolution of the network and cloud infrastructures. Such evolution includes both scale and complexity. Traffic growth, user growth, and mobility expectations have driven the expansion of network infrastructures, particularly in the access and last mile. Likewise, the migration to the cloud and cloudification of applications and services has resulted in more agile and flexible architectures, but at the same time, much more complex to manage, operate, and understand. And I need to come back in just a moment. All right, I'm back. Something is burning, but it's an apartment complex, so it must be a neighbor cooking. Last but not least, increased competition in the markets, particularly in the service provider space, results in more than ever sensitivity to capital and operational expenses. It is usually referred to that for each $1 in and this must be the author must not be English as a first language, or if they are, they must not be from the USA, because in the USA we would put the dollar first. So I mean, that's fine. I just wanted to point that out there because so far it's been a little bit tricky for me to read. It is usually referred to that for each $1 in Capex, there are $5 yearly Opex associated. The consequence is tremendous pressure on Opex, primarily driven by people. So this is an advanced book. You have to know what these terms mean. I think I know what they mean. I think Opex means operational expenses, and I think Capex means capital expenses. So like a capital expense would be, so okay, and I'm going to talk to ChatGPT about this. Okay, so the next thing, I'm reading a book, and you see the book I'm reading, right? It's Machine Learning for Network and Cloud Engineers. So it's kind of an advanced book that assumes you know some basic terms. So one of the terms is Capex, Capex, and the other term is Opex, Opex. So my understanding of these terms, and I believe I do understand them, is that the first term stands for capital expenses, and the second term stands for operational expenses. And the difference between the terms is a capital expense is something you need to start something up, and you only need to pay it once. So in order to drive a car, a capital expense would be the price of the car. It would also be the price of the registration and the price of like, let's say you needed a windshield scraper for snow. That would be a Capex cost as well. Now the Opex cost is the cost to operate the car. So when you get gas, that's an operational expense. When you need to take it in for a maintenance, that's an operational expense. Is my understanding of these terms correct, or is there something problematic in the way I understand them?
Your understanding of Capex, capital expenditures, and Opex, operating expenditures, is fundamentally correct, and you've outlined a good analogy with the car example to differentiate between the two. Here's a bit more detail and clarification to ensure your understanding is comprehensive and precise, especially in the context of networking or cloud engineering. Capex, capital expenditures. Definition. Capex refers to the funds used by a company to acquire, operate, and maintain physical assets such as property, buildings, technology, or equipment. This is typically a one-time cost for long-term benefits. In your example, the cost of buying a car, registration fees, and any initial equipment like a windshield scraper or indeed capital expenditures. In the network or cloud context, Capex will include the cost of purchasing hardware like servers, routers, or data center infrastructure. Opex, operating expenditures, definition. Opex includes the costs associated with the day-to-day running and maintenance of business. These expenses are ongoing, recurrent, and typically necessary to keep the asset operational. In your example, costs like buying gas, regular maintenance, and any other costs required for the daily operation of the car are operational expenditures. In the networking or cloud field, Opex would cover things like electricity bills, cloud service subscriptions like AWS or router, network monitoring tools, and staffing costs related to system maintenance and management. Considerations. Differences in accounting. Financially, Capex and Opex are treated differently in terms of accounting. Capex usually impacts an organization's balance sheet, as these assets can be depreciated over their useful life.
Yeah.
Opex, on the other hand, is deducted from the company's profits in the year they're incurred, affecting the income statement directly. Decision making. Decisions on Capex versus Opex can significantly affect the company's tax position and cash flow. For example, shifting from Capex to Opex by leasing equipment instead of buying it can reduce upfront costs and provide tax benefits. Your analogy correctly captures the essence of Capex and Opex. This understanding is crucial in strategic planning, budgeting, and managing technology resources, especially in fields involving high upfront costs like network infrastructure or cloud computing environments. Your grasp of these terms should serve you well in both professional discussions and in interpreting the financial aspects of IT and network management as described in advanced texts like one you're reading.
All right, I'm happy with that. Yes, I'm correct. We are therefore in a perfect storm for network and cloud engineers. Expectations from the infrastructure are higher than ever. The complexity of the infrastructure is also higher than ever, and human resources are more limited than ever. At this point, I am probably not saying anything you don't know already, or at least anything you do not suffer daily. This is the fundamental reason why automation has gained so much interest in the past years in networks, IT, and cloud infrastructures. Configuration management tools, service provisioning tools, and workflow automation tools have become pervasively deployed, either using commercially available products or leveraging open source community-driven alternatives. Either way, these tools have one key attribute in common. They are all intended to automate actions that otherwise would need to be executed by humans. Whether configuring one device when it is initially deployed, activating a service configuration, or doing a software upgrade, these are all tasks that can now run in an automated manner, improving the predictability and quality of the outcomes and the execution time. Nevertheless, they all still depend on someone clicking the button. Yeah, exactly. Someone deciding what needs to be done, exactly. Why, when, and where. The how is now automated, but everything else is not. However, networks are increasingly more complex. The expectation is that they must run at higher performance and reliability, and resources are more limited. Still, someone must rightfully decide the what, why, when, and where for those actions. Lots of decisions to be made under more time pressure and stronger SLAs that must be met. This takes us to the next era in network and cloud automation. If the current era has been about, and we've got a highlighter thing. Oh, so I guess they want this to be highlighted, or it's so anyway, this takes us to the next era in I need to get rid of that. That's annoying me. How do I get rid of it? There we go. If the current era has been about automating actions, the next era of network and cloud automation is about automating decisions. And there's so much like use in that. Like, when do you upgrade a link? Like, you know, if you do that perfectly, then it's better than if you don't. It will be about how we produce more and better. And also, like, when do you upgrade a link? And when do you do traffic engineering? Like, yeah, those decisions have to be automated. It will be about how we produce more and better decisions that can feed automated actions. It will be about how we help network and cloud engineers take decisions faster or delegate basic decisions in autonomous agents, while the human supervises the same and focuses on the more complex decisions that need to be made, design decisions, complex problems, etc. Okay, so we're going to delegate to the AI the simpler decisions. So basic decisions will be sent to autonomous agents, and then the more complex decisions will be made by humans. Okay, so automation today, we automate actions. The automation of tomorrow is automating decisions, which already this book has a 10 out of 10 for me because that's a wonderful insight. Decisions require data and some thinking process, which translates the data available into an outcome. Making decisions is something inherently human. As you will see in the following chapters, artificial intelligence is a set of disciplines intended to make machines imitate human behavior, and one such behavior is making decisions. I hope you have understood at this point how critical AI/ML is for networking and cloud infrastructures, and as a consequence, how important it is for you to know about them. I am not saying you have to be a data scientist, but you need to know the art of the possible and how the algorithms work and can be applied. Likewise, while you are not a router software developer, you have a good and probably better than good understanding of BGP or EVPN, and know how it works and how to apply it. I see AI/ML as the new toolkit of technologies you need to understand to become a better network and cloud engineer and be a better professional. Perfect. This is what I'm trying to do. Also, note that this book is not specifically about AI ops. AI ops and observability are certainly fields of applicability of AI/ML to networks and clouds, but those are not the only ones. Throughout the network and cloud lifecycle, multiple tasks must be executed, and every task has some associated decision. Every decision is potentially a target for ML, machine learning, whether in the design, planning, deployment, provisioning, or operation stages of the infrastructure life cycle. This book is not about learning AI ops. It is about you learning ML so you can have a holistic understanding of the opportunities across the network lifecycle of using ML and be able to take action on them. All right, who is this book for? So I'm going to add a bookmark here. There we go. So this page is now bookmarked. It doesn't have the fancy ribbon, but if I click show bookmark here, so we've got a bookmark on page 1. That might be a bug bookmark. We've got a bookmark here as well. I'll delete that. And I'll add this bookmark back. And we might have a buggy bookmark where an extra one shows up, which is a little bit annoying, but it's better than one not showing up at all. So I'll take that as a bug. Thanks for watching, and stay tuned. And I'll if the book's not for me, I'll know in the next video.